go to even higher, right? And this becomes more difficult for you, right? So you need to solve higher order differential equation. That's one. Secondly, you need to solve nonlinear differential equation. That's two. Thirdly, you need to solve parallel differential equations, or what we call system equations. What is system equation? That's this. Take a look at this. System of equation, which means you have multiple sets of equations. 联立方程式. Do you remember when we show you this? We said solving fx0 is easy, remember? Then we say, what about solving this? Remember this? Remember this? This is only one equation, right? This is like, yeah, a set of equations, right? And this becomes more difficult, remember? For solving this or for doing optimization, do you remember that if using Newton's method, remember the formula. The Newton method is xi plus 1, doing optimization. Jacobian inverse, remember this? And partial f. Do you remember this? Yeah? So solving this is more difficult because if it is only this is simple, like there's no vector because this is 多变数, single variable, right? And this one will be equal to what? Fx and fx prime, right? You remember that? Right? So this is 牛顿法，但是解联立方程式的时候，它就变成比较复杂，要做 Jacobian 去了，是不是这样 ？Jacobian. So likewise, when we have a set of equations like this, what we call systems of equations, and this becomes more complicated, right? But if you are solving using your hand, 就是你在公数的时候，你用手计算 ，this is difficult. This is difficult. However, for numerical method, this is still the same. Still the same, easy. Very easy, because what? Because you have this equation, and this equation, all of them, all doing the doing this process, the same. 你每一个 equation 都是一样做这件事情就好了，然后把它叠下来就完了。So what I'm saying is this: for engineering mathematics, this becomes very difficult, but for numerical method, it's the same. It's the same because it's all done by parallel programming of this equation. Right? Right? Think about it. Okay, so that's easy because we'll show you examples later. Maybe let me just say a little bit about this. So you have, for example, this guy. This is, let's say the first one, y1, y2, right? So what we can do is this. We can say this is y1, I plus 1. Let's put this I plus 1 on top now, okay? Equals y1 I plus h times phi 1, right? And this would be phi 1, right? And then you can say ti, t, right? And then also y, something like that, right? And you can plug in ti, and this is like y here, right? And then the second one is y2, I plus 1 equals y2, I plus h, phi 2. And ti, and this is y, actually we should put here, ti and y, this is y2, and I like this. So this is y1 and I like this. It's a little bit confusing, you know, because sometimes put here, sometimes put up here, right? But you know what I mean, right? 你知道我在讲什么？ 就是那个 i 加1跟 i， 我现在只把它放到上面 y1 y2 y2。你要把 1 放到上面 ，i 放到下面也可以啊，都可以的啊。Same thing until yn I plus 1 yn I plus h by n ti and y. Here we also need to put like here. So this is I, this is n, right? Now remember doing this. Actually, I'm a little bit incorrect because this is not yi only anymore. Because in this equation, because instead of equation, here I made a mistake. You see why? Because I need to do this. This actually becomes y, let's say y1, I, y2, I, all the way to yn I, because it should be all in this equation, right? Same thing here. It should be y1 I, y2 I, and all the way to yn I. Should be all inside. Same thing here. y1 I, y2 I, and all the way to yn I. Because they are functions of all these variables, right? And that's fine. That's fine. You do the calculation. You update y1, y2, y3, yn, right? 因为你每次做计算的时候，这边虽然都有 y1, y2, y， 但没关系，你都是 i， 那你算完了就得到这一排了，对不对？你算完这，然后把这一排再带进去下一次的 iteration 啊，全部把它带进去啊 ，right? What I'm saying is this. Every time you have y1, y2, yn, but then it's I, and then you get y plus 1 from y1, y2 to yn here, right? So in the next iteration, you bring all of this back in here, and also in here, and in here. So it becomes y1, y2, y, I plus 1, I plus 1, I plus 1, right? And here will be I plus 2, right? So you get the next iteration. Okay? So this method tells us it doesn't matter how many n you have. It's the same. 一样的简单，就是联立方程式而已，对不对？我的意思是说，你这边算完的每一次算完的得到的都会是一个新的 y 的值 ，y1、y2 到 yn， 然后你把这些所有的结果再带回来算下一次，对不对 ？So it doesn't matter how many n you have, you can use it. So this is very powerful. If you are doing by hand, it's big headache. 你用手去算的话，你就要头痛啊。Okay, so try to understand this. Okay. 对啊。你说 least square 不是，我以为你在讲 discrete 啊，不是，这跟 least square 不一样，这只是在一次不断的迭代。第一个 equation 做完，第二个 equation 它们都没有问题，因为他们都会拿 initial value y1, y2 到 yn 都有 initial value， 因为这是 ODE 问题，不是要给你 initial value 吗？所以 initial value 都会给你啊，然后你就不断的算完这边，然后再带回去这边做下一次的迭代啊，就这样。Okay, 不是 ，Okay. Now, so this is a little bit more abstract for you to understand， 就是有点不容易理解。But let's use this example, okay? Let's use this example. The reason this is basic and easy to understand should be easy to understand. You're just doing this parallelly. Now this is related to this. 这两个是相关的。In engineering mathematics， 在公数里头的时候，你做这个跟做这个是不一样的哦。你公数里头，你这个叫做 higher order function， 就是高阶的微分方程式。这个叫做联立，低阶的联立方程式，因为它都只有一次微分。这个是低阶的微分方程式，这是高阶微分方程式，你感觉上不一样。高阶的微分方程式怎么做？其实这两件事情是有关的。These two are actually related. These two are actually related. Why? Let me show you. Let's take this example. This example originally is second order differential equation, higher order. So originally this example, let's take a look, is dy over dt, right? This is dy over dt, right? And actually is second differentiation. D squared y over dt is squared dt squared. Okay, this is true. Okay, like this. So this is equal to g minus cd over n, and this is dy over dt squared. The original problem is the second order differential equation, right? 原来的问题应该是二阶的微分方程式嘛 ，right? Now we can make this into a first order differential equation. 我们可以把这个问题变成一阶的联立方程式，把高阶的微分方程式转为低阶一阶的联立方程式。We can turn the second order differential equation into a set of first order differential equation. Okay, so how do we do that? Let's do this. What we do is we have y1 and y2. Okay, so y1, let's say y1 equals y. Okay, and y2 equals y dot or y differentiation or y prime. Okay, so this one you can say y dot or y prime. That's fine. Let's say y prime. So if y1 equals y, y2 equals y prime, right? And then we have y2 prime or y2 prime equals y double prime, right? Is that correct? y2 prime equals y double prime, right? And y double prime, according to this equation, equals what? This is y double prime, right? Or y double dots, right? It will be equal to this. It will be equal to g minus cd over n and times dy over dt. Dy over dt is this. It's y prime, right? So this is equal to y2 squared, right? Is that correct? Yeah. So there's no y1 inside, okay? But through this, we'll write two differential equations. One differential equation is y1. This is y1, okay? There's y1. Y1 is here, right? So y1 prime. Y1 prime, because y1 is y, so y1 prime is y prime, right? And then y prime equals y2, remember? y1 prime is y prime, and y prime equals y2. So y1 prime equals y2, right? And then y2 prime equals, over there, g minus cd over n and y2 squared. So you actually have two set of equations. 联立方程式。那这边右边呢 ，this is, so this one equals phi1. This one equals phi2. And phi1 is the function of t, y1, and y2. Of course, here it's only y1, only y2, no y1. But generally, it's also a function of y1 and y2. So you can use the Ranch-Kurta method to do this, or you can simply just use Euler method to do this. So, in other words, we make this higher order differential equation into a set of differential equation, a set of low order. Actually, it's only 一次微分 differential equation. 这样了解意思吗? You understand? Okay? So, by doing that, we actually literally can also use this same concept to do this and this. Let me try to show that to you, okay? We can also use this concept to do these two equations, higher order equations. So let me try that, let me show that to you. Okay? So let me show that. Let's take this equation, higher order, second order, higher order. So for the second order, higher order, let's say again, let y1 equals y, okay? it always begins with y1 equals y, because there's this second order differential equation. And now y1 equals y, and then we have y1 dot, or y1 prime, let's use dot right now, okay? y1 dot equals, sorry, let's make a correction here. I said y2 equals y1, y dot, okay? y2 equals y dot, and y dot equals, because y equals y1, so that equals y1 dot, right? Is that correct? So y2 equals y1 dot. And same thing, y3 equals y double dot. And y double dot is y, because you have y2 equals y1 dot, right? So this is like y2 dot, right? Is that correct? So y3 equals y2 dot, right? And we actually, this actually goes to this, because this 3 means we have this cubic order, okay? But now we only need to use this and this, actually. We only need to use this. We don't need to use this. We will later use this for cubic equation, but let's take this out right now. So, let's see. Maybe we need it, because this is only two equations. Yeah, okay, sorry. Yeah, we need it. Yeah. y3 equals y double dot equals y2 dot. Okay, that's it. Okay, y2 dot. So let's take a look at this equation. Let's take a look at this equation. It says y double dot. Y double dot from here. This is y double dot. And y double dot equals y double dot, right? Y double prime equals y double dot. Which is this, right? Which is this. And that equals this, right? So that equals y2 squared. Oh yeah, we only need this. We only need this, okay? So y double dot equals this, equals y2 dot, okay? And y2 dot equals, look at this, y2 dot equals this. Moving over to this one, it's minus ay dot minus by plus ft, right? That becomes like this. Now notice, this would be equal to minus a y dot. Where's y dot? Y dot is here, right? Y dot is here. This is y dot. So minus a times y2. That's y2 here, right? And plus, or minus b times y. And where is y? Y is here. Y is here. Y is equal to y1. So this is y1 plus ft. Okay? So, in summary, we have y1 dot. Because y1 dot is where? Y1 dot is here. Y1 dot equals y2. And y2 dot equals what? Y2 dot equals this. Here. So y2 dot equals minus a y2 minus b y1 plus ft. So now we have this equations. Okay? So you see, we can solve this equation for this, because this is second order equation. Just like this. This is second order equation. So we have this too. Okay? We have this too. Same thing, you can do this, right? Because if using this, again, you have another one, which is this, you can use. Because this one is y3 dot. For this one, this will be y3 dot equals, moving over to this side, minus a y double dot minus b y dot minus c y and plus ft, right? But this one equals minus a times y double dot. Y double dot here is y2 dot. Sorry, y double dot is y3, so this is y3. Minus b y dot here is y2, right? y2. And this is minus y1, right? cy1 plus ft. So, with this equation, you have another one like this. You can set up another set. And then this set, this one equals, this will become here, one more. This one is y3, right? For the third equation, y3 dot equals minus a y3 minus b y2 minus c y1 and plus ft, right? And then y1 dot is still y2 and y2 dot is y3, right? So then again, 3 sets of equations for this one, and originally 2 sets of equations for this one, right? So you can use this method to do higher order differential equations, right? And then they all become first order. 从把高阶的方程式转成一阶的微分方程式，高阶的就会变成联立的一阶的微分方程式，就这样 ，OK？ 这样了解吗 ？OK？This will be very, very useful, as I will show you later. 这个要把它搞清楚啊，因为这个非常有用，考试必考。考试必考 I will show you. I'll give you test problems, okay? In the final or midterm, okay? I'll give you. So this is very important. Concept, very important. You need to understand this because we will have problems for you. You have to solve that in your exam to get your score, okay? Okay? Okay.